What I want to do in this video is get a little bit of practice trying to approximate the area under curves and also get a little bit more familiarity with sigma notation in this context. So what we have here, we have the graph of f of x is equal to 1 plus 0.1 x squared. That's this curve right over here. And then we have these rectangles that are trying to approximate the area under the curve, the area under the function f between x equals 0 and x equals 8. And the way that this diagram, or the way that we're attempting to do it, is by splitting it into 4 rectangles. And so we could call this rectangle 1, this is rectangle 2, rectangle 3, and rectangle 4. And each of their heights, let's see, the interval, it looks like they each have a width of 2, so they are equally spaced. So we go from 0 to 8, and we split into 4 sections, so each has a width of 2, so they're each going to be 2 wide. So that's 2, that's 2, that's 2, that's 2. And their height seems to be based on the midpoint. So between the left side and the right side of the rectangle, you take the value of the function at the middle value right over here. So for example, this height right over here looks like f of 1. This height right over here looks like f of 3. This height of this rectangle is f of 5. This height right over here is f of 7. So given the way that this has been constructed, and we want to take the sum of the areas of these rectangles as an approximation as the area under this curve, how would we write that as sigma notation? And I'll get us started, and then I encourage you to pause the video and try to finish it. So the sum of these rectangles, we could say it's the sum of, so we'll have n equals 1 to 4 because we have 4 rectangles, and I encourage you to finish this up. Actually, just write it in terms of the function. Use function notation. You don't have to write it out as 1 plus 0.01 times something squared. So I'm assuming you've had a go at it. So for each of these, for the first rectangle over here, we're going to multiply 2 times the height. So the height right over here is 1, and this is the first rectangle. So you might be tempted to say times f of n. But then that breaks down as we go into the second rectangle. The second rectangle, the 2 still applies. This 2 is the width of the rectangle. But now we want to multiply it times f of 3, not f of 2. So this f of n isn't going to pass muster. And so let's see how we want to think about it. So when n is 1, 2, 3, 4, we're going to take f of n, or not, I should say f of n. We're going to take f of something. So here, this first one, we're going to take f of 1. Then here, for the second rectangle, we're taking f of 3 for the height. For the third rectangle, we're taking f of 5. And then, so for the fourth rectangle, we're taking f of 7. So what's the relationship over here? Let's see. It looks like if you multiply by 2 and subtract 1, so 2 times 1 minus 1 is 1. 2 times 2 minus 1 is 3. 2 times 3 minus 5, 2 times 3 minus 1 is 5. 2 times 4 minus 1 is 7. So this is 2n minus 1. So the area of each of these rectangles, the base is 2, and the height is f of 2n minus 1. And so that hopefully makes it a little bit clear, kind of mapping between the sigma notation and what we're actually trying to do. And now let's just for fun, let's actually try to evaluate this thing. What is this thing going to evaluate to? Well, this is going to evaluate to 2 times f of, when n is equal to 1, this is 1, f of 1, plus 2 times, when n is 2, this is going to be f of 2 times 2 minus 1 is 3, f of 3. But when n is 3, this is going to be 2 times f of 5. When n is 4, this is going to be 2 times f of 7. 4 times 2 minus 1 is 7, f of 7. And so that is going to be, well, we're going to have to evaluate a bunch of these things over here. So let me clear this out so I have a little bit more real estate. I'm feeling this might get a little bit messy now. So this is going to be, actually we could factor out a 2. So this is going to be equal to 2 times f of 1 is 1 plus 0.1 times 1 squared. So it's 1 plus 0.1, so it's 1 point, let me color code it a little bit just so we can keep track of things. So this right over here is 1.1. So 1 plus 0.1 is 1.1. This right over here, f of 3, so that's 1 plus 0.1 times 3 squared, 9. So 1 plus 0.9. So 1 plus, so it's 1.9. And then, let's see, this one right over here, f of 5, that's going to be 1 plus, see, 5 squared is 25 times 0.1 is 2.5. So 1 plus 2.5 is going to be 3.5. And then finally, f of 7, is going to be 1 plus 0.1 times 7 squared. So this is 49 times 0.1. 49 times 0.1 is 4.9 plus 1, so plus 5.9. Plus 5.9. And so what is this going to be equal to? So let's see, 1.1 plus 1.9. These two are going to sum up to be equal to 3. And then these two are going to sum up to be, let's see, if we add the 5, we get to 8.5, and then we add the 0.9, we get to 9.4. So plus 9.4. Did I do that right? 3 plus 5 is 8. 5.5 plus 0.9 is 1.4. Yep. And so this is going to be, so once again, we have the 2 times it all. So this is going to be equal to 2 times 12.4, which is equal to 24.8. which is our approximation. Once again, this is just an approximation using these rectangles of the area under the curve between x equals 0 and x equals 8.